So today we're going to have a review of logarithms, and sometimes you don't really like logarithms in Algebra 2, and that's often because they're brand new and they're a little strange. But then when you see them again the next year, you like them more, or they make more sense. So logarithmic functions and their graphs. So if x is greater than 0 and a is not equal to 1, then this logarithm y equals log base a of x. If and only if x is a to the y. I like to take this part right here, and I like to rewrite it as log base a of x equals y. I like it to be in the form of the problem equals the answer. And I also like to take this side and rewrite it as a to the y equals x, because I like it to be the problem equals the answer. That's the form I like it in, because a few years ago on Pinterest, I saw this thing where you could do the swoop. And the swoop, if you saw the way I did it, goes through the outside and the outside and through the middle. So if you follow the steps of the swoop, you would see that I can change a logarithm to an exponential just because a to the y is equal to x. So if you follow the steps of the swoop. And you can also change an exponential to a logarithm by doing the swoop. So that would be log base a of x is equal to y. So that takes you back and forth between these two forms. You don't have to use the swoop. I confess, a little bit addicted to it. I do like it. I think it's a quick and easy way to go from one form to the other. Let's see. I want you to know that the logarithm asks a question. If I have log base 5 of 25 equals 2, it asks the question, 5 to what power is 25? So 5 to the second power is 25. That's why the answer to the logarithm is 2. The answer is the power. You can use the swoop to write this exponential that I did. 5 to the second power is 25. So it's really handy to go back and forth between the two forms. So first off, if you'd get your calculator out. And we're going to calculate to the nearest 3 decimal places. Let's say we've got f of x equal to log base 2 of x. Let's find that answer if x is 32. So on your calculator, you're going to be able to work out f of 32 by doing log base 2 of 32. So you can go to math and you can arrow down to log base, and it will bring up this blank logarithm for you to fill in. Or you can do math alpha, which is usually the green key, and then math, and it also brings that up for you. So it's just whichever way you want to use to get there. This is math down to log base is how you get this. Or you can do math alpha math. So one way or the other, do log base 2 of 32, and hopefully it gives you 5. And that's because 2 to the 5th is 32. All right, another one on the calculator. Let's do log base 10 of x, and let's do x to be 1/100th. So you're going to do log base 10 of 1/100. I'm going to go to the next screen to do this. I'm going to work it out a different way, but you can just plug it into your calculator. And I'm going to say, well, I wonder what that's equal to. I'm going to set it equal to a box, and I'll do my swoop. 10 to some power is the same thing as 1 over 100. So you can change 1 over 100 to 1 over 10 to the second. Then you could bring 10 to the second to the numerator by making that a -2. So this answer should have been -2, because the logarithm asks, what's the power? 10 to what power is 1 over 100? You don't have to think through that, though. There are no x's here. You can just plug that into the calculator. Math alpha math. Alrighty. So we have been talking about the LOG logarithm. This is called the common logarithm because it's understood to have a certain number here as its base. The base is understood to be 10. Unless they change it like they have changed it here. And that's fine. But if there is no base written, then it's understood to be the same thing as log base 10 of x. And if you just hit the LOG button on your calculator, you only get to use that when it's a base 10. Otherwise, you have to do the math alpha math and change the base. Okay, so common logarithmic function uses a base 10. We have 4 properties of logarithms. These are nice. This chapter overall is pretty nice. It gives us a break from all that stuff we did in chapter 2. What if you have log base a of 1 and we want to know what that's equal to? Well, let's do the swoop. Or think, a to what power would give you a 1? But I'm going to do the swoop. A to some power is 1. When we make the power be 0, a number to a 0 power is 1. So the blank is 0. A to the 0 power is 1. That's one log property. Property 2, log base a of a is equal to something. So you can think log is asking the question, a to what power is a? Or you can do the swoop. A to some power is equal to a. Well, if this is an equation, and if these two things are both equal with a's as their bases, and the one on the right has an understood 1 power, then this must also be 1 because they're equal. So the left equals the right. They're in the same form. So this would also be 1. Property 3, log base a of a to the x is equal to something. Well, if we do the swoop, a to something is equal to a to the x. These are equal. This is an equation. They're in the same form. So the box must be x. And this is kind of a inverse property, because if I took the swoop away, let's look at it the way it was originally. It's kind of saying if the log base a of a, where a is a base, they kind of cancel each other, and that's just equal to that power. That actually worked at property 2 also. Log base a of a, they sort of canceled each other, and that a really had a 1 power. Property 3 has a b part. It is a to the log base a of x is equal to something. Well, when you look at this problem, it's got a logarithm in it, but it's not a logarithm question. It's an exponential question. I've got a base raised to a power. So when I want to do the swoop to rewrite this, this is an exponential, so I'm going to rewrite it as a logarithm. Log base a of something is equal to the thing we just went through last, that log base a of x. Well, these are equal. This is an equation, so the box must be x. And this is also one of those kind of inverse things. If you have a as a base and it's raised to a log with that same base, they kind of cancel each other, and it's just equal to the x. Last property, maybe one of our favorites. Log base a of x is equal to log base a of y. Oh, I should have put an if in the front. If log base a of x is equal to log base a of y, then something is equal to something. Whoops. Something. Okay, so if the logs are equal up there and the base a's are the same, then that means that x must actually be the same thing as y. So you would see that as something like log base 4 of 12 is equal to log base 4 of what? And you'd say, oh, x must be 12. Okay. Oh, maybe I should give you an example of 3b also. Maybe it's something like 7 to the log base 7 of x. Well, 7 to the log base 7 cancels, so this is just x. All right, so that took us through the common logarithmic function. Now we'll talk about the natural logarithmic function. Do you remember what the natural base is from the other day? The natural base is e. Euler's number. The natural logarithmic function is ln, and it has an understood base of e. This is your natural logarithmic function. If you are dealing with e as a base, then you're going to use the ln logarithm 99% of the time. It's not wrong to use the log, but these go together like peanut butter and jelly. So if we have e, we want to use ln. If we have an ln, we have an understood base of e. And if you use the ln button on your calculator, which is under the log button, you only use it if it's got an understood base of e. And actually, the calculator expects us to always use a base of e with ln. So there is no way to change, that I know of, to use the calculator to change ln for a different base. Like we have a way to change the common logarithm to have a different base. We do math alpha math. There is no way to change ln, as far as I know. So the natural logarithmic function, all the properties for it are the same. Properties of natural logs. A part, no, 1. ln of 1 is equal to what? Well, let's remember what its base is. If it's not written, it's understood to be an e. So we can do our swoop. E to what is 1? 0. So this is equal to 0. The second one, ln of e equals what? Well, with our understood base e. E to what power gives us an e? Or we can do our swoop. E to the what is e? Must be 1. Third one, 2 parts for it again. ln of e to the x is equal to what? Give it its understood base. Do the swoop if you'd like. E to what is e to the x? Well, the what must be an x. And you could use the inverse property. Give yourself the understood base. Ln base e of e as a base. Those cancel, and it's just x. And so 3 had a cousin, 3b, and it was e to the ln of x is equal to what? We can do the swoop. E to the what? Oh, wait a minute. So did I write that right? Yep. Yep. Oh, wow. I just about got myself in trouble. What is this equation? Its form. Is this a logarithmic form or is this an exponential form? This is exponential. This is e to a power. So when I do the swoop, I'm ready to write it as a logarithm. And I would do ln because e and ln go together like peanut butter and jelly. All right, so finish the swoop. Understood base of e, so that box must be an x. Last one. If ln of x is equal to ln of y, then what must be true? Then x must be y. Because this is an equation, and those two logarithms are equal, so their bases must be, what we're taking the logarithm of must be equal. All right, let's just use the calculator a little bit with logarithm, make sure we feel okay. Pick up your calculator, find the ln button on the left side under the log button. So if we're dealing with ln of x, let's figure out the value if x is 0.3. So do ln of 0.3. And hopefully you got approximately negative 1.204. One more. Let's figure it out if x is negative 1. So you did the ln of negative 1. It said error because we can't take the log of a negative number. That's way back here. I don't know if I talked about that enough. In order to take a logarithm, x has to be positive. And your base can't be 1. So there's that. And I think that wraps us up. So I gave you some problems in the book. Every other odd, I believe. And I'm copying a worksheet for you. And you're just using your calculator to work stuff out. And you are going back and forth between the two forms. You're doing the swoop. All right, I'll see you all Wednesday.